Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Further Pure Mathematics 1 for the 2020 exam series, question 6, requirement C. Show that the acute angle between the planes ACD and BCD is inverse cosine 1 over root 3. To find the angle between planes, we'll work with the normals of the planes using the equation cosine theta equals the dot product of the normal of plane 1 and plane 2 over the magnitude of the normal of plane 1 times the magnitude of the normal of plane 2. To find the normals, normal 1, we want the cross product of AC and AD. Both of these vectors are in the plane ACD. And for normal 2, we want the cross product of BC and BD, both in plane BCD. Starting with normal 1, I'll set up a table to calculate my minor determinants, I, J, K. I'll put signs to remind me to apply -1 to the minor determinant for J. Now, working with AC, I want to subtract C minus A for I, J, and K. Those values are -1, 0, and 4. The same for AD, D minus A, -1, 1, and 5. When I work through the minor determinant calculations and simplify, I have normal 1 equals -4i plus j minus k. For normal 2, setting up the table, I, j, k, plus, minus, plus. Here, c minus b for I, j, and k. 3, -1, and 5, and then d minus b, 3, 0, 6. When I work through the calculation of the minor determinants, I have normal 2 equals -6i minus 3j plus 3k. Now we have the values we need for the angle calculation. Cosine theta equals, in the numerator, the dot product of n1 and n2. I'll multiply the I values, -4 times -6, adding the product of the j values, 1 times -3, adding the product of the k values, -1 times 3. In the denominator, the magnitude for normal 1 will be -4 squared plus 1 squared minus 1 squared. I'll multiply by the magnitude of normal 2, -6 squared plus -3 squared plus 3 squared. When I simplify, I get to cosine theta equals 1 over root 3, and theta equals the inverse cosine of 1 over root 3. This cosine value is positive, which confirms that the angle we've calculated is acute. If in this kind of scenario you end up with a negative cosine value, you can simply comment that the negative cosine value relates to the obtuse angle, and that the positive of the same cosine value represents the acute angle. This completes the requirements for question 6, part C.